the result of minus b over 2a is actually a shortcut coming from calculus. It is a shortcut coming from calculus. And what I want to look at now is I want to ask the question, where does it come from? Where does minus b over 2a come from? Are you guys with me? Okay. Where does minus b over 2a come from? Now guys, I'm going to show you the steps. Given a curve y equals ax squared plus bx plus c, can anybody tell me what curve this is? What type of curve is this? It's a quadratic curve, right? And that's called a parabola. Okay. Now the other day you learned something called the power rule. And when we look at the power rule, remember when we use the notation y, then we must use dy by dx, which stands for the derivative. And what did I say the derivative is? It's the same as a gradient at a point, which is the same as the gradient of the tangent at that point. Very good. Okay, can anybody tell me what's the derivative equal to for this function? Okay, come guys, what's the derivative? Iman, how do you do this? You take the 2 and you multiply it by the coefficient, which is what in this case? It's not 1, it's 2a, right? Because remember, this is generalized now. 2ax to the power of 1. And whatever's in front of x, we put that down and the constant term falls away. Okay, by now you've mastered the power rule, right? Okay, so do you all agree with me? What I found now is called the derivative of the function. dy by dx is equal to 2ax plus b. Now this is for a graph that is the parabola. So I'm going to show you a parabola like that. And I'm going to take a point. Do you see this point? What point is that? It's the turning point. And what can I do with that point? I can do what? I can zoom, right? And when I zoom that point starts to look like what? It starts to look like a straight line. Now if I draw a line through that straight line, remember that line is going to look something like this. Do you see that? If I draw a line through that line, like that, right? I have a question for you. Tell me what's the slope of that line that you see there?
Straight, flat, 0.
Right, so there's no slope, which means that the gradient m is equal to 0. Are you guys all with me? The gradient is equal to 0. Is it always 0 on this graph? Who says yes? Raise your hands.
Huh?
Who says no?
On that graph.
Is the gradient always 0 on this graph? No. But where is it 0?
On top. Turning point.
At the turning point. So that's a concept I need you to make a note of very quickly. NB, the gradient of, very important, the gradient of a polynomial function at its turning point is equal to 0. Now guys, do you all have that down? So let's go back to this thing. Remember the derivative, this is for the gradient at a point. Now I'm going to put this on a new page. Firstly, let's revise the concepts here. The one concept is that if I take a point, I zoom in infinitely, and I draw a line through that point, that line now constructs a tangent, right? And you know the tangent has the same gradient as the gradient at that point, right? Now we've looked at this thing here. This is the derivative. And how did we get this derivative? We used the shortcut called the power rule. Okay? And when we use the power rule over here, I need you to notice the following. I'm going to put this on a new page. dy by dx, that's just the name now, is equal to 2ax plus b. This thing is a function. In other words, you throw in an x value and you'll get out a derivative value. You'll get out the gradient. You'll get out what? The gradient. But I have a question for you. The gradient at the turning point is equal to what? It's equal to 0. The gradient at the turning point is equal to 0. So, do you need to put in an x coordinate to find the gradient at the turning point? No, because you already know for a polynomial function the gradient is equal to 0. Now we are going to work in reverse. Okay, so I'm going to put 0 in here and I'm going to say 2ax plus b. Now I want you to solve for x. How do you solve for x? We take the b over, I'm left with minus b equals, and then what do? I divide both sides by 2a, and this cancels, and therefore x is equal to minus b over 2a. So guys, I'm going to reflect on the steps taken here, okay? And then we are going to extrapolate that steps to the cubic graph. Because remember when we started this section, we said everything we're going to try and relate old knowledge to new knowledge, right? And I said this thing is a result from calculus. Okay. So now very clearly people, when you deal with the parabola, you simply used to take minus b over 2a, and what do? You substitute that. Do you put it in this function? No. You put it in this function. So you substitute into f of x. Are you guys with me? You substitute into f of x. Are we good? Yes, no? Okay. So do we all now know where does the minus b over 2a as the x coordinate come from for the parabola? What did we do? What were the steps here? Step 1, find the derivative. Step 2, we made the derivative equal to? Why did we do that? Because we know the derivative or the gradient at the turning point is equal to 0. Then what did we do? We solved for x. And then what did we do with that x? We took it and we put it in f of x. So we take that result and we put it back into the original function. My question to you is, how many steps are there? 4. Very good. Okay.